Very warm welcome. This is Amit. I will be your discussion partner today. And today we are going to talk about infrastructure as code using Terraform, right? So we will start with understanding the use cases. What is infrastructure as code? Why do we need it? And then we'll talk about use cases of Terraform. Then we are going to understand the architecture, how Terraform works, right? What are the various components? Then we are going to see a little bit of demo, right? So it is ambitious to cover all these things in 1 hour, but let's try our best. All right.
Amit, how
So
about the doubts?
we'll spend around last maybe 10 minutes for Q&A.
Okay, thank you.
Yeah, we have to plan it judiciously, so 10 minutes should be fine. Okay, so
So Amit, are you from the Terraform? HashiCorp, is it? I sorry, I didn't get the introduction, so I was just trying to get the details.
okay, so I am not from HashiCorp. Well, I am uh, um, a full-time software engineer working as a principal engineer or principal architect for DevOps in one of the organizations. And
Okay.
I also like to teach, um, propagate my learnings. So that's why I also take, teaching batches for Kubernetes, for Terraform infrastructure as code, everything on the DevOps, right? Everything on the DevOps
Okay.
horizon. I talk about, I teach, um, and that's what I do, and that's who I am,
Okay.
right?
Oh, that's really good. Thanks for sharing these details because I mean, I was not aware on this.
Yeah,
I
yeah.
just
I mean,
got this email and then I just was pretty surprised that who is going to take this training and then wanted to get some details. So
yeah,
yeah,
yeah.
that is
No,
really good that you are going to give this training. That is really helpful for us.
yeah, I'm glad. Um, I just kept the introduction short because only 1 hour. Yeah.
Okay. Yeah.
So yeah, but thank you for getting this out of me. Okay, so now let's talk about what Terraform is, right? Before that, let's talk about what is infrastructure as code. I'm not sure if you guys have already worked on some aspects of infrastructure as code, but let me just summarize this in 2 or 3 minutes. Infrastructure as code essentially means managing your infrastructure as a piece of code, as you manage the code, right? As you manage the code. That means everything required to set up, configure, and use your infrastructure, well, it is all done through code. You write configuration files, you write some scripts, whatever is required, you write those as piece of code, and this piece of code is translated into your infrastructure setup, infrastructure configuration, or if you want to use the infrastructure. Okay, for example, let's say you want 10 servers, right? Let's say you have got 10 virtual machines. Let's say you got 10 virtual machines, and these 10 virtual machines have to be configured for certain use cases. For example, maybe you have a Jenkins infrastructure and you want to use this machine and this machine for running your Jenkins server, right?
Amit,
Yeah,
sorry to
sorry.
inform you. Are you sharing
Are
your
you?
screen?
Yeah.
Oh, okay. All right, all right. My bad.
Because you said this machine and this machine, so I thought you trying to share something, but it's actually it's not happening.
Oh, okay, okay, okay. I'm really sorry. Can you see my screen?
Now, yes, we can see that. I can
Yes.
see that.
Yes.
Okay, good. Thank you for pointing it out. So I was talking here, right? Let's say we have 10 servers, and the 10 servers have some uses, right? For example, these two machines act as Jenkins server or Jenkins control node. Then you have some build machines which you will connect to Jenkins, right? Just as an example, maybe these are your build nodes, And these are the machines where you're going to run your Git or any Git based hosting service like GitHub or GitLab or Bitbucket or whatever. And let's say these are some machines which you, oh come on, hold on a sec, this crashed. Yeah, and these are machines, for example, to um, maybe part of Kubernetes cluster, right? So you got 10 servers and you have to configure these servers for specific use cases. How will you generally approach this problem? You will find someone who has understanding of server management, right? Maybe a Linux administrator or somebody similar, and you ask this guy to change the configurations or to configure the servers according to the use cases. So this guy, well, if he's not using infrastructure as code, he has to log in to each machine and make appropriate configuration changes. Like, for example, install Jenkins package or set up SSH keys or create some users or create some files, install some services, whatever is required. So this person is supposed to log into each server and manage the server, right? Now 10 servers is okay, doable. This person can manage 10 servers. Imagine that you got 10 more teams, each having these 10 servers. Now you got 100 servers. One person is not enough, right? So you have to scale up. Maybe you hire 5 more people, or you hire 5 more people to manage the infrastructure. This is again not scalable. You add more servers, you want more people. Yeah. So how do we scale this server configurations and server management? Right? That's one problem. Second problem is, how do you ensure that this configuration which you make or install on all these servers, they stay there, right? You ensure that the state that you want your servers in is actually persistent. Nobody can maliciously log into this server and delete a user or delete a file, right? How do you ensure that the server configurations are persistent and consistent, right? That's one more problem. So these problems are solved by infrastructure as code. You don't actually log in into the servers and make the configuration changes. You define the configurations as piece of code, right? You write a small configuration file and say, hey, I want this in my server, and feed it to an infrastructure as code tool, and that tool will take care of configuring your servers, right? Let's observe that diagrammatically. So let's say you got, let's say, 2 servers, right? You have got 2 servers, and it is your task to manage these servers, to change the configuration and install required tools and all that. Okay, how will you go about it when you use infrastructure as code? What you're going to do is, let's call this as server 1 and server 2. You're going to write a small configuration file called as manifest, right? You write a manifest, and this manifest is written as piece of code. Now the syntax can be dependent on which infrastructure as a code or ISE tool you are using. Based on that, you have to define the syntax, but it could be YAML, it could be HCL, which we will talk about, it could be Ruby. Many options are available. Now you write this manifest. In this manifest, you specify what configuration you want for S1, what configuration you want for S2, and then define those configurations for S1 and S2. And then you feed this to an ISE tool or ISE engine. Now, ISE engine will understand these configurations, how you have written, because you will write it in a format which is understood by ISE engine, right? You feed it here, and then ISE engine is going to connect to these servers and get these servers the required configuration, right? So whatever is defined here will be configured on these servers. Okay. Now, the next question would be, well, if we can automate the configuration of the servers, can we also automate the provisioning of the servers? Let's say we start a project tomorrow, a team starts a project tomorrow, and they realize, well, we need 5 servers, 5 virtual machines. What would they do? In traditional companies, traditional organizations, they will reach out to IT, they will place a phone call, or they will reach out to someone or raise a ticket or whatever is the process, and they will ask for 5 servers. IT is going to then plan a purchase of those 5 servers, or the hardware that is required, right? And then they are going to budget it, they are going to procure it, and then they are going to deploy it, and then they will hand over the servers to you, right? And it may take time. The turnaround time with such procurements is very, very high. And specifically when we have this microprocessor and processor shortages, it's even going beyond 1 year for certain kind of servers, right? For example, in my organization, uh, some very specific users, including me, are waiting for i9 laptops, and there's so much shortage that the lead time for getting the laptops is around 8 months, right? So imagine about the most frequently used servers, the blade servers or Xeon servers. So anyways, coming back, so you want servers quickly, but IT cannot guarantee that, right? Now let's say you have a cloud subscription, you are working on AWS or Azure or whatever. Now with this cloud subscription, you get the flexibility to get the servers on demand, right? Now, I'm not sure if you have worked with AWS or any other cloud provider. One of the major selling points of the cloud providers are virtual machines. So in AWS, they are called as EC2 instances, right? And within a few clicks, you can request instances. You can say, I want 10 core, 20 GB, and with 1000 GB hard disk server with Ubuntu. If you have your requirements already ready, you can just maybe have 4 or 5 clicks and you get your server, right? And your team can start logging into that server and start producing code or producing product or whatever they do, right? Now, if your team requires 10 servers, let's go back here in this example. If your team requires 10 servers, well, somebody has to ensure that these 10 servers are created by click, 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 click. Each of these servers may have different configurations. Then for each configuration, the person who's responsible of creating these servers, they are going to perform these repetitive tasks for creating the servers, right? This is where Terraform comes in. So Terraform is also kind of an infrastructure as code engine, but instead of configuring the servers, Terraform enables you to create servers, right? So this diagram changes a little bit.
Yeah, hi, Amit. We are not able to hear you. Maybe I guess you are muted yourself.
Somebody muted me, I guess. Were you able to, where did you lose me?
My screen is also not visible.
Now we can hear you.
Now it's fine actually.
Screen is visible?
Yes. Yeah.
Yes.
Yes. Yes.
Okay. What was the last thing that you heard?
The diagram needs to change.
Okay. All right. So the diagram needs to change now. Now we are not looking for configuring a server or servers. We are looking for provisioning servers. We want new servers to be set up, right? Guys, hold on your questions. We will answer the questions later, right? If you ask now, they may get lost in the many chats. Okay, so now we don't want configurations, or we don't want to configure a server. We say, hey, our team requires 2 servers, and for these servers we have these requirements. For example, 1 core, 2 GB RAM, 80 GB hard disk, or whatever, right? And you can have requirements here as well. And then you feed this to Terraform. Now, Terraform is a tool which integrates with your cloud services, right? It can be AWS, it can be Azure, or it can be Google, or Alibaba, or whatever. So now you define what you want and give it to Terraform. Terraform is going to connect to your cloud by native authentication, and in the cloud it's going to do whatever is required to set up those 2 servers, right? You specify, I want these servers with these configurations, and you feed it to Terraform, and Terraform talks to the cloud environment and gets your servers there for you, right? That's what Terraform does. That's all that Terraform does. You can also again, I'm not sure if somebody has rights to mute or unmute people, because I just now also got muted automatically. Okay, so please refrain from muting me. Thank you. Okay, so yeah, Terraform is used for managing your servers, or I would say all the components on cloud. So it's Terraform cannot just create servers for you. It can create VPCs. It can create elastic Kubernetes service clusters, EKS clusters. It can create instances, can create security groups, whatever you want, whatever component you want to manage on the cloud, it can manage it for you, right? So as a team, if you want to set up your entire environment, let's say you want to set up a deployment environment, as a team, you can specify that I want to create 1 VPC with some configurations, 3 security groups with some configurations, then some NACLs, right? Then some instances. I want to create all these things to get my deployment infrastructure. And you can define this in this manifest file, give it to Terraform, and Terraform will create everything required for you in the cloud. Yeah. And you can also tell Terraform or ensure that Terraform keeps an eye on the cloud to ensure that whatever is configured is actually existing on the cloud. Right? It will ensure that whatever is defined, whatever state is defined of the components is actually existing on the cloud all the time. If somebody goes and deletes the instance, Terraform should automatically replace that with a new instance. Okay. So now how does Terraform do that? Well, let's clean this board. Well, Terraform actually has various components. You can install Terraform on your machine, on your laptop or a desktop, and you can write your configurations in Terraform config files or Terraform manifest. These files can have any name but ends with extension .tf. Okay, so you can specify I want 1 AWS EC2 instance and with some configuration, maybe another EC2 instance with some configurations. You can define that and then feed it to Terraform. Now Terraform actually uses something called as providers. Okay, Terraform has a integration with many cloud providers, right? As I said, Google Cloud, AWS, AKS, not AKS, Azure, any cloud, right? Now, to interact with your cloud services, for example, AWS or GKE, not GKE, GCP, or your Azure, well, it has to talk to these clouds. So Terraform should know how to talk to these clouds, what features are available on AWS, what components are available on GCP, how to authenticate to them. All those intelligence has to be provided by Terraform, right? Now, Terraform engine itself does not have that information. So what Terraform does is it allows these vendors to build Terraform compatible providers, or called as plugins, and it'll say, hey, AWS, you are developing your cloud platform, develop a provider also so that Terraform can integrate with AWS. So the AWS team will develop a provider for AWS. The Google Cloud team will create a provider for Google Cloud. Azure team will create a provider for Azure. Similarly, all other cloud providers can create providers to connect to their infrastructure. Then when you write a code, and in the code you say, I want to create all these or have all these configurations in Azure, then the TF engine will understand that, hey, I need to connect to Azure. Let me download the Azure related provider on the system and then use it to connect to Azure. Similarly, if you say, hey, I want AWS resources to be created, then the Terraform will download AWS and then connect with AWS. Okay. So the providers provide the intelligence, or I would say the platform intelligence, to interact with various platforms. One TF engine can connect to multiple cloud instances by using multiple providers. All right. And that's all it does. Now we will see a couple of demonstrations, and after that, if time permits, I can also tell you about plan and execution, but let's see how much we can cover. So on my laptop, I have Terraform, right? So I'll go to 5. Give me a second. Yeah. Get a new directory, Terraform DF. So I created a directory called SkillUpRight. It's just a plain directory. I'm using Windows PowerShell here. You can use Batch if you're working on Linux or Mac. You can use specific terminals. Everything should work everywhere. Okay. Now I need to install Terraform. If I execute the Terraform command, I should get this output. Okay. Now, if you do not have Terraform already installed, I have it here. So you see this output. If you do not have Terraform installed, then you can look for Terraform installation. Pretty easy. You can see here for Windows, if you have 64-bit or if you have 32-bit, you can download Terraform versions. It's going to download a zip file, and then you can unzip it and put it in path. Okay. All right. So once you unzip it, you will get Terraform, and you should be able to run Terraform like that. Then now let's say I want to create an AWS instance. That is our demo example. We want to create an AWS instance. So for that, let me show you how you create AWS instances normally using GUI. So I can go to my AWS account and I'm stopping my screen share because I have to authenticate to my AWS account. Let me do that. All right, so I'm into my AWS account here, and you can see some common services that I use. I'm going to create an EC2 instance. I'm going to go to EC2 service. Yeah, and then I'll say, well, I want to create an EC2 instance. Let me first delete these existing instances. Yeah, I want to create an instance, so I'll just click on launch instance, right? And I want to create an instance based on Ubuntu. Okay, so I'm going to choose an AMI of kind Ubuntu. What's an AMI? AMI is short for Amazon Machine Image. It's an adapted operating system based on some operating distribution. For example, they have taken Amazon has taken Ubuntu Server 2004 and then added some Amazon specific features in that, and then that they call it Amazon Machine Image, so that it can readily work with Amazon infrastructure, right? So each operating system has an AMI ID. So if you want to run an x86 based system, you need to use a specific AMI ID. For 64-bit ARM, you have a different AMI ID. So you have AMI IDs which uniquely identify an operating system image on Amazon in a particular region, right? You can read later about AMI IDs, but they identify a specific operating system in a particular region, right? So I'm going to use this AMI ID. I'll just make a note of it for later. I'll just keep it like that. So I'm going to use Ubuntu server, and I'm going to create a T2 micro instance. Right? It comes free with the free tier, and I'm free tier eligible. So I get this option to create T2 micro, which is nothing but 1 CPU and 1 GB of memory. You can choose any other configuration based on your requirements, right? For example, if you want, you can choose a 96 core and 192 GB machine as well. All right, coming back, we are going to create a T2 micro instance. Click on configure details, and I'm not going to change anything else here. Nothing changing here. Nothing changing here. Security group, well, yeah, I can say use this particular security group which already exists for me. I will also take a note of it because I'm choosing this. I'm not going with the default values. Click on final review, and I say launch. And I also choose which SSH keys I want to use with my instance, right? So Terraform key I have already created, so I just leave it that. And within few seconds generally, but sometimes within a couple of minutes, you will see this instance powered up, and you can connect to this instance via SSH and do whatever you want, right? This is how you can provision a server. Now, if you want to create 100 servers, you have to do the same steps 100 times, right? Or you can write maybe your own scripts, some own patch script, but again, it will not be as efficient as Terraform. So now let's use Terraform to create this instance, right? I'm going to delete this again here. I don't want it to eating up my free quota. Okay, Now what I'm going to do is I'm going to go to Terraform documentation. Terraform AWS. I want to create an AWS instance. I want to work with AWS Cloud. I want to use Terraform to connect to AWS. I just look for it and it takes me to this location, registry.terraform.io, HashiCorp AWS latest. Okay. So this is the place where you can look for the providers. For example, if you want to connect to AWS, this is the provider. And you can see all the documentation from the provider and you can see what things, what components, what features of AWS you can use or manage using this provider. So on the left hand side, you can see you can manage your app config, you can manage your Cloud9, right? You can manage your code commit repositories or code build pipelines. You can manage your Elastic Container Registry, Elastic Container Service, EKS, EFS, anything you can manage. Yeah, EC2 instances you can manage. So now we want to use this provider and we want to use Terraform to get an instance up and running. What I'm going to do is I'm going to go to this place where I have created this directory and I'll say, hey, I want to use this directory as my Terraform configuration directory. First thing I should do is I should say Terraform init, right? This is going to initialize this directory as my Terraform directory. Now, unfortunately, we do not have any file in here. So it says Terraform initialized in an empty directory and it has not created any configuration files. So we have to write some configuration files so that Terraform can understand it. Okay. Now, first thing is that we want Terraform to be able to use this provider. Terraform should use this provider, right? As I showed in the in this architecture, Terraform cannot connect to the cloud providers directly. They have to use a provider. So we say, all right, because we are going to create an instance on AWS, let's use an AWS provider, right? And this is what we have to do. Here you can see use provider button in this documentation. You can click on it and immediately you will see a quick code snippet which you can add to your Terraform code, right? I copied it. Here it says to install this provider, copy and paste this code into your Terraform configuration, then run Terraform init. All right, I'm going to do that. I copied it. And now I go to this directory and I create a file called provider.tf. I don't have Vim, so not sure if it's going to work. I'll use it Notepad. I'll just plainly use Notepad. So I open provider.tf. Do you want to create a new file? Yes, please. And in the Notepad, now I'm going to write my code. Terraform is a code block. Then here inside it, it is required providers. And then inside it, list of providers. So I have only one now. I say AWS. Then, okay, what is the provider name? The provider name is HashiCorp AWS and version is 450. And then if I want to configure the provider, I can make some configuration files as well. Just like that. This syntax is called HashiCorp configuration language or short for HCL. And it is used by all HashiCorp products, be it Vault, Console, or Terraform, right? So now we are going to save it. This configuration will tell Terraform that in this directory, whatever code you will see, it has to talk to AWS. Now I'm going to say Terraform init. Now Terraform init actually found a file and it says installing provider plugins, finding the plugin HashiCorp AWS, which we provided in this code, and version 450 of that. And it says, yes, it found it. It is installing it. So it downloads and keeps it in this directory. Terraform has been successfully initialized. Right? So now here, I run this command called tree. A tree command prints the directory structure up to the last file, or I would say tree hyphen f, I guess. So tree will print out the complete directory structure up to the last directory. Tree/f will print out the complete directory structure up to the last file. It will show me all the files here. So inside D drive, inside this folder, you have .terraform folder, and in the .terraform folder, we have a providers folder created, and then it specifies from where the providers are downloaded. So this is the location. Then who's the vendor? HashiCorp. What is the provider name? AWS. What is the version? Then what is the architecture? And then finally the provider. So you see this exe file. This exe file contains all the intelligence about how to connect to AWS. So Terraform has downloaded this provider and kept it here so that whenever we are going to actually run our Terraform code, it's going to use this provider to connect to AWS. Okay. All right. So this provider is downloaded and initialized. Now we are going to write quick code here. So now next thing is, well, the provider should be able to talk to the cloud, should be able to authenticate to the cloud to access your account. So you need to also provide some authentication. Right? So unless your provider has authentication details, it cannot talk to the cloud provider. Well, it can talk, but it cannot authenticate. So how do you provide authentication? Well, for authentication, you can, let's go back to the documentation here. And if you scroll down on the root of the documentation, if you scroll down, you see some documentation for authentication. So I can, in the provider configuration itself, I can specify the region I want to connect to, the AWS region, the access key and the secret key that I want to use. Right? Now, if you have worked with AWS, you know that access key and secret key is a combination which can be used in place of username and password for automations. That's what we are going to use here. Okay, so I'm going to copy this code block, put it here. So you see there was a template of AWS provider, but I put this. So now when I run this, whenever I will, when I write any AWS or whenever I write any Terraform code and it uses AWS provider, it's going to use these configurations for that provider. It's going to create whatever components in this region by authenticating using this access key and this secret key. Now here I have to fill in my actual access key and secret key. So let me create that. It's very sensitive operation, so you should not actually do this, or I should not be doing this live for you. But since I'm going to delete it later, let me do it now. So I go to my account, click on security credentials, and it takes me to my security dashboard for my account. I click on access keys and I click on create new access key. It is done. And this is the access key and this is a secret key. Access key. And this is a secret key. Right? I saved it. Authentication is taken care of. Generally, I use AP South 1 region, so I'm going to use that region as well here, so that all the resources will be created in this region. Now my provider is set up. Now I want to create an EC2 instance. I will go to this documentation and I'll go to EC2 in the resources. I'll say, well, EC2 instance. Do we see any something called as EC2 instance? AWS instance, right? This resource definition, if I specify in my Terraform file, I can specify if I want to create an EC2 instance. Okay, for example, I'll just choose a minimal documentation here, minimal code here, something like this. So I say I want to create a resource, a cloud resource. What is the resource type? What kind of resource? That's the second parameter. AWS instance. I want to create an AWS instance. All right. In Terraform, I want to refer to that instance as web. Right? Okay. Now Terraform says that all right, with this configuration, you will be able to create an AWS instance and you can refer to it as web. Okay. Now, if you remember, to create an instance, we have to provide an AMI. So AMI has to be provided. It's a mandatory parameter. I have kept a note of that AMI, so I'll just copy it and provide it. Use this AMI. I can also put it in double quotes or without quotes is fine. This is my AMI. Then what instance type I want to create. So if you remember T2 micro, T2 nano, all those are instance types. So I can say here T2.micro. Create an instance, AWS instance called web. The instance type should be T2 micro, AMI should be this. And then we can give it optional tags. This is not mandatory argument, so I can maybe comment it out. And with this, if I take this, I save it, and I go to my Terraform command line here, and I say Terraform apply. Just give this auto approve. We come back to that later, maybe not. Yeah, but with this, or maybe I'll just show it to you. I say Terraform apply this configuration, whatever I have written. Press enter. It's going to read my Terraform file and it gives me this output. After Terraform apply, it says Terraform uses selected providers to generate the following execution plan. That means it's going to create or manage these resources. So it's going to create some resources. This is one resource, AWS instance.web. This is a resource that will be created. This is the AMI ID will be used. This is the instance ID will be used, and all other things will be either automatically generated by AWS or will be used by default. For example, security groups, it will be used by default. The default security group will be used. Okay. So with this, it's going to create my instance. I have to approve this action. So I say yes. Now Terraform is going to talk to my AWS account and it's going to create an instance for me. Right? So now you can see this realizing infrastructure as code is managing your infrastructure as piece of code. And to create that infrastructure, we just wrote this 4 lines code. Right? And if I go to my AWS account, and if I go back to services, EC2, and go to instances, you will see a new instance is created. Right? Now I can add something else. I can say, well, I want to add a tag to this instance. So I'll say from Terraform. I want to give this tag, this name tag to this instance. I save it and then I go back here. You can see the previous operation has successfully completed. I apply the configuration again because I changed something. Terraform is going to analyze this updated configuration. And here it's going to say that configuration has changed, right? Tag has been added. It's going to update the instance in place. That means it's not going to delete the instance and create it again. It's going to just modify the configuration because adding a tag does not require destruction. So yes, please do this. and it's modifying, and it created that tag, right? If I go here and if I just refresh, you will see now this instance has a tag name called from TF. So I'm managing this entire instance as a piece of code by writing whatever is required by me as piece of code and let Terraform perform the actual heavy lifting and actual actions. Right?
Yeah.
So that's what I wanted to talk to you about. Since we have reached the time for Q&A, we can spend last 8 minutes for Q&A. Although I think it was a very small demo, we can talk about a lot of things. But yeah, questions, please.
Yeah, Amit, this is Vijay, and I have one question. Not regarding the actually, basically, I do work on the Azure cloud, and I'm using Terraform to create VMs and other resources, multiple VMs. Multiple VMs. So think that. Uh, so I
I cannot hear you.
hello, Amit, I'm audible now.
Yeah, I just lost you. Can you repeat? Yeah.
Yeah. So basically, I'm working on the Azure cloud, uh, and I do create multiple resources using Terraform. I I have been stuck with one stage where I need to add multiple data disk using for each loop. So I can able to create a static IP, VM with static IP. But while creating the data disk and attaching, it's not. I'm not able to find the code and what would be logics.
Okay, so that is very, very specific question.
Yeah.
um, uh, I do not have an answer for you on top of my head. Maybe if we do a little bit of debugging and do a little bit of exploration, I can find it for you.
Yeah.
But unfortunately, at this point of time, I cannot help you just like that. I'm really sorry.
Yeah. Not an issue. So how can I?
So if you are asking for, I lost you again, but if you're asking for how you can
Yeah.
find the documentation and find help, well, you can always, first thing is you go to the documentation, right? So you can browse providers.
Yeah,
Uh,
Amit, sorry to
yeah.
interrupt you. I can see that, but think that I'm trying to add disk dynamically. Like suppose if I'm creating two VMs and I'm mentioning two disk has to be added. So means each VM must have two additional data disk, and that is logic is not working for me. I tried searching over the internet, but I did not find a suitable help, or you can say is code. Even though I tried in the
So you are
uh,
saying you are creating two virtual machines, and let's say you are whenever, so how much ever virtual machines you are creating, you have to create those separate data disks for them and attach them.
yes, yes, that's what only I'm thinking. That's what I'm planning.
So, I mean, you can use again, let's say, are you using Blob?
Yes,
You're
eh,
creating Blob, is it?
yes, yes, I'm creating the blobs.
Okay. So in, I mean, you can, well, what you can do is you can use variables, for example, and you can define the count variable.
No, no, Amit, the thing is that I am using, so for count, I'm able to use, I need, because I'm using in production.
Mhm. Okay. So as I said, yeah, this may require a lot of debugging
Yeah,
and interactive session.
yeah,
So yeah, it's not feasible to find an answer immediately.
yeah, yeah, sure. But so if how can I contact you? I don't know if you give me a
Contacting
contact.
me won't be possible, unfortunately. Yeah, that's something you can talk to these SkillUpRight people. They can direct you.
Yes, sure. Thank you. And I don't know why somebody is muting me intentionally or how
Yeah, yeah,
every
that
time I'm
happens.
getting
Yeah,
mute.
it was happening to me also. Okay,
Yes.
let's go for next question. Question.
Hi,
Yeah.
this is
Okay.
Rahul.
There are some questions on the chat. I'll just quickly take them. TF state file. I think you meant state file. So I have not covered it, but state file is a file which contains the latest updated state of your cloud infrastructure into your uh, into your local state file, and only the components which are managed by Terraform are stored there. How can you do debug in Terraform? Well, a lot of it could be trial and error. A lot of it could be when you run Terraform command. Yeah, you can, for every command, you can have some options. For example, okay, I can see, I cannot see it here, but yeah, there is an option to produce more verbose output. So you can do that as well. But yeah, a lot of Terraform usage has to, I mean, you cannot just use Terraform without knowing your cloud components. And you have to actually understand a cloud provider as well before you actually use Terraform. So yeah. What if the TF file is deleted? Can we restore it back with all the VMs? Your TF files should always be in version control. Okay, so please always check them in so that you can always track what is happening. Why to use Terraform when we can create an instance in AWS? I have already explained this. Okay, now I can take, okay, there are some questions. Is it possible to protect it, Azure or AWS secrets using Key Vault or Secret Manager? You can do that, but generally what you should do is you should store your secrets in your home drive. Yeah, generally Terraform is used on personal machines. If you are integrating it with Jenkins or any other automation tool, then you can use Key Vault or something like that. Yeah, you have to be really careful with the secrets. And that reminds me, actually, I should delete this secret. Yeah, you guys all know it, so I will delete it to prevent any misuse. Terraform versus Puppet versus Ansible, which one is better? Okay, such questions never work. It is like asking you have two kids and which one is better, right? Each one has their own advantages and disadvantages. We have not mentioned the VPC details in Terraform. So what will be the taken it by default? So by default, a VPC is already exists on a cloud account. So for me also, a VPC exists already. If I go for VPC, I can so you can see here there is a VPC that already exists and it is the default, right? So that's what it used. Are you planning to conduct any further Terraform trainings in future? SkillUpRight would be the team to answer it properly. Can we install MySQL directly when launching the instance through TF? You can do that. You can use something called as the data input for any instance creation. If you have used it, you can write some bash scripts and mark your instance to execute them as soon as they are created. So there you can write installation scripts as well. What level of technical support is available on Terraform? You can go for Terraform Enterprise and you can explore that. Is it possible to configure any approval workflow in Terraform and based on approval form the request manager? So you have to define your own tooling for approval workflow. You can use Jenkins, for example, for that. But if you have to take an approval, then maybe that's not the best DevOps practice, but there could be some organizational challenges to do that. So you can use any other tooling. Terraform inherently does not provide that. How to unlock, rollback a locked or corrupted TF state file. So you can do a TF sync or TF refresh. I don't remember that command. You can have a state management using Terraform state command, right? So you can do that. Is Terraform used only for provisioning? Yes. How to integrate Terraform with Tecton pipeline to automate any talks? As of now, I'm not aware. I use Tecton pipelines, but that's for CI pipelines. I wouldn't recommend using Tecton pipelines for Terraform. What providers are required for on-prem VMware deployment? So this you can explore by yourself. So for example, maybe if I go to provider and here somewhere, do we have VMware? So we have VMware vSphere, right? Maybe you can use that. Yeah, you can create virtual machines, so you can use that. How to manage Terraform admin by allowing only few users. So as I said, Terraform is not a separate service. Terraform is a tool which you use locally. If you are saying that you want to restrict usage, then you have to restrict usage on your cloud account. Can we use Terraform for creating some resources like AWS Azure App Services? Yes, why not? If you go to Azure, you can click on documentation, and there could be app service, right? You have app service here, and you can create it. Can we also use Terraform to define the whole application architecture, central stack upstream? Whatever you can create on cloud, you can manage that. That's what I can say. Okay, we are already beyond time, but I can spend 2 more minutes. Any questions? Verbal
Hi,
questions? Yeah.
hi, this is Rahul. Uh, Amit, I have a team here. It comprises of a dedicated infrastructure management person, and there is a development team which handles the Azure development. So we sometimes report this kind of thing, that sometimes developers do go and manually they create the resources. Okay, and when we try to stabilize and standardize the process by using IAC from the infrastructure side, we experience that sometimes when they kind of recreate the same infrastructure setup which was created manually earlier, there happens to be some kind of erroneous things that the Terraform fails, or it does not kind of create the resources properly, or there are certain things like the network connections or the network definitions, they don't happen properly. So is that a speculation, or it actually is a reality? Because we are not clear yet why it happens.
So if you have a resource already created, yeah, and many times a resource has a unique ID, right? For example, an
Okay.
instance, when you create an instance, it has a unique instance ID. And if you want to create a new instance using the same value for that unique ID, then Terraform may fail. Now that's the one thing which I can immediately
Okay.
talk about. But I'm sure you would have figured this out already,
Yep.
if this was happening. Rather than, apart from that, I don't think Terraform should behave in this way. If you have some resource created using Terraform, if you are creating the same resource, you are not actually creating a same resource, you are creating similar resource, right? You
Exactly.
created something manually, you want to replicate it using Terraform. That's not
Yeah.
the same resource. That's a similar resource with a similar
Exactly.
configuration. And Terraform should not be behaving that way. Terraform does not have that intelligence that, hey, this VPC with this CIDR is already created, I cannot do that in another region CIDR. So that should not be there.
Okay.
I would say maybe something problem is somewhere else.
All right. And if I may take a minute more related to another thing. Suppose there is a scenario that we have applications, right? They are meant to be externally facing on the internet, but only on production when we do the DNS cutovers, which are exposed to internet, right? But for testing them, there are different lower environments, which basically are non-prod environments. So there, we need to restrict them via the corporate VPN only, right? So we need to restrict the users to be using the lower environments when they are logged into the corporate VPN. So for that, we typically use the network hub and VPN tunneling. So I just wanted to understand, is there a possibility that we can handle all the VPN tunneling and IP restriction and the firewall whitelisting, everything using Terraform? Because we have not been doing that yet.
Yeah.
That has been taken up by the NOC guys.
Yeah. So I'm not sure about VPN. I'll be really frank with you, but your firewall, your instance level firewalls,
Mhm.
your NACLs, that is your VPC level firewalls, that all can be managed.
Correct.
Yeah, that can be managed.
All right. Thanks. Thank you, Amit, for your time. Thank you.
Okay. Thank you for interesting questions, and thank you for giving me the opportunity to talk to you. And most of all, thank you for paying attention. It was really pleasure talking to you. For any further support, you can connect to SkillUpRight. And yeah, thank you.
Yeah,
Take care.
thank
Be
you,
safe.
Amit.
Hi, Amit. Just a question. Do we get this recording? Like, I could see if somebody
The
has
SkillUpRight
recorded.
team can answer you. Yeah,
Okay.
I'm sorry, I do not
Yes,
have
you will
any.
get.
Yeah.
Yeah, thank you, Amit. Thank you for a nice session.
Thank you. Thank you. Bye.
Bye bye.
Okay, bye.